Hello, my dear students. Let us continue with active and passive earth pressure. The mode diagram, this is the mode diagram, which is a convenient tool for studying the stress conditions at equilibrium, both before and at yield in the soil. Okay, you can see here, this is active case slip lines and this is passive case slip lines. Okay, so this is the major principal stress and here this is the minor principal stress and angle is 45 plus 5 by 2. In the case of passive case, here this is the major principal stress and this is the minor principal stress and which makes an angle of 45 minus 5 by 2. The stress diagram is like this. This is the vertical stress and this is the horizontal stress. Vertical stress, that is just gamma into z, and here that is the horizontal stress. You have to consider the coefficient of earth pressure. So K into gamma into z. Okay, let us discuss about this more circle. Here figure shows the active and passive state of plastic equilibrium in a non-cohesive soil with the horizontal ground surface. Now let us consider for cohesion-less soil, okay, where C is equal to 0. In an active state, this is the active state, this is the passive state. In an active state, the major principal stress sigma 1 is vertical and the minor principal stress sigma 3 is horizontal. Circle 1, this is the circle 1 which represents such a state in which the pole P1, this is the pole P1 which is corresponding to the minor principal stress, that is horizontal stress or lateral pressure. While point A, this is the point A which is corresponds to the major principal stress. Okay, here P1 corresponding to minor principal stress and A is corresponding to major principal stress. The circle touches the failure envelopes at F1 and F1 dash. This circle which touches the failure envelope, this is the failure envelope at F1 and F1 dash. And hence P1 F1 and P1 F1 and P1 F1 dash show the directions of the failure planes or slip lines. These slip lines have also been shown in the figure. Okay. Similarly, for the passive state, the minor principal stress is in the vertical direction, while the major principal stress is horizontal. This is the passive case, and here minor principal stress in the vertical direction and major principal stress is in the horizontal direction. Circle 2, this is the circle 2 and this is corresponding to the passive state in which the pole P2, this is the P2 corresponding to the major principal stress and the circle touches the failure envelope here and here, that is at F2 and F2 dash. Hence P2 F2 and P2 F2 dash are the directions of slip lines corresponding to the passive state. This is about active and passive states of plastic equilibrium. You should know how to explain using Mohr circle. This is for active case and this is for passive case. Okay. So in the active case, major principal stress is in the vertical direction and minor principal stress is in the horizontal direction. But in the case of passive state, major principal stress is in the horizontal direction and minor principal stress is in the vertical direction. This is the slip line P1 F1, P1 F1 dash, and here P2 F2 and P2 F2 dash are the slip line. This is for active, this is small circle, that is for active state and this is for passive state. Okay. Now let us discuss about coefficient of earth pressure. What is this coefficient of earth pressure? This is the ratio of horizontal stress that is sigma h, to the vertical stress sigma v, that is called as coefficient of earth pressure K. Okay, so coefficient of earth pressure is equal to the ratio of horizontal stress to the vertical stress. When the soil is in active state of, first we will see for the active state, when the soil is in the active state of plastic equilibrium, so that sigma h, that is equal to sigma 3, and sigma v is equal to sigma 1. Okay, now this equation, in the last class I explained about this. This is the formula for sigma 1 is equal to 2c tan 45 plus 5 by 2 plus sigma 3 tan square 45 plus 5 by 2. But we are considering for non-cohesive soil or cohesionless soil. So C is equal to 0. So when you substitute C is equal to 0 in this equation, this term becomes 0. So the remaining is sigma 1 is equal to sigma 3 into tan square 45 plus 5 by 2. So if you write it like this, sigma 1 divided by sigma 3, that is equal to tan square 45 plus 5 by 2. So that's why it is written like this, sigma 1 divided by sigma 3. But this is for active state. In the active state, sigma 1 is equal to sigma v. So it is sigma v divided by sigma h, that is equal to tan square 45 plus 5 by 2. So here active earth pressure or earth pressure, it is coefficient of earth pressure, that is the ratio of horizontal stress to vertical stress. So horizontal stress divided by vertical stress, that is equal to active coefficient of active earth pressure Ka. Okay, but so this is equal to K is equal to sigma V divided by sigma H is equal to tan square 45 plus 5 by 2. But we have sigma H divided by sigma V. So that is equal to 1 divided by tan square 45 plus 5 by 2. I hope all of you understood, because sigma V divided by sigma H or sigma 1 divided by sigma 3, that is equal to tan square 45 plus 5 by 2 based on this equation. But active earth pressure, that is equal to sigma h divided by sigma v. So that is equal to inverse of this, that is 1 divided by tan square 45 plus 5 by 2. That is nothing but cot square 45 plus 5 by 2 on equal to 1 minus sin phi divided by 1 plus sin phi. Where so Ka is equal to 1 minus sin phi by 1 plus sin phi, that is equal to coefficient of active earth pressure. So similarly, we will solve for passive state. Here sigma h, horizontal stress, that is equal to sigma 1 now, and sigma v is equal to sigma 3. So if you write in terms of this equation like sigma 1 divided by sigma 3, if you substitute C is equal to 0, get sigma 1 divided by sigma 3, that is equal to tan square 45 plus 5 by 2. But in this case, sigma 1 is equal to sigma h divided by sigma v, that is equal to tan square 45 plus 5 by 2. So this is equal to, now we have to write equation in terms of passive earth pressure. So Kp is equal to horizontal, that is the ratio of horizontal stress to vertical stress. So that is sigma h divided by sigma v, that is equal to tan square 45 plus 5 by 2. That is nothing but 1 plus sin phi divided by 1 minus sin phi. Okay, so this is Kp. So Ka is equal to 1 minus sin phi divided by 1 plus sin phi, that is coefficient of active earth pressure, and Kp, coefficient of passive earth pressure, is equal to 1 plus sin phi divided by 1 minus sin phi. When the soil is at elastic equilibrium, that means at rest, it doesn't change its position, it remains same. The ratio of horizontal to vertical stress is called the coefficient of earth pressure at rest. So that is sigma h divided by sigma v is equal to K naught. It is represented by K naught. K naught may also be computed from the following approximate expression, that is equal to 1 minus sin phi. So K naught is equal to 1 minus sin phi. So it is to be noted very carefully that earth pressure at rest P naught is always greater than active earth pressure but lesser than passive earth pressure. Okay, this you have to remember. The earth pressure at rest is greater than active earth pressure but less than passive earth pressure. Okay, so this is about coefficient of earth pressure. Next we'll see the variations of earth pressure and coefficient of earth pressure with the moment of the wall. So now here you can see this is the lateral pressure, the pressure at rest, this portion, and minimum pressure, this is the maximum pressure. Okay, this is the passive pressure, this is the active pressure, this is pressure at rest. The magnitude of the lateral earth pressure depends upon the moment of the retaining wall relative to the backfill and upon the nature of the soil. So this figure shows the variation of lateral earth pressure with moment of the retaining wall. Okay, so in this figure, the variation of coefficient of earth pressure with the horizontal strain is shown. Okay, here point A, which represents the earth pressure at rest. This is the earth pressure at rest. When the wall moves away from the backfill, mobilization of the internal resistance of the soil, which builds up in directions away from the walls, takes place, and hence the earth pressure on the wall decreases. The decrease of earth pressure continues up to B. This up to B and the full resistance has been mobilized. The earth pressure does not decrease beyond this point with further movement of the wall. This minimum pressure is called the active earth pressure. Okay. If on the other hand the wall moves towards the field, the earth pressure increases because the shearing resistance builds up in the directions towards the wall. The pressure reaches a maximum point C. Here, this point is C, when the shearing resistance of the soil has been fully mobilized. Any further movement of the wall does not increase the pressure. This maximum pressure is called the passive earth pressure here. For this is about this is the diagram which shows the variation of earth pressure and coefficient of earth pressure. You can see this is the active state away from the field and this is the passive state towards the field. This is the passive pressure and this is at rest and this is active earth pressure. So from here to here this is PA, active earth pressure, and this is the pressure at rest and this point, and from here this is the maximum pressure, that is passive pressure. So here only you can make out P naught is always greater than PA but smaller than PP. Okay, I hope all of you understood this. If you have any doubt, we can discuss in the class. Thank you.